Polyurethanes are one of the most widely used and versatile of all the plastics and have become a necessary part of everyday life. Polyurethanes can be flexible in form or rigid to suit their uses. Their application ranges from use in large buildings to the soft fillings in furniture and clothing. We walk on them, travel protected by them, sit and sleep on them. In everyday life, polyurethane not only provides a comfortable support, it also provides valuable protection and safety. Polyurethanes have often proved to do a better job in use than many of the conventional materials which they've now replaced. For example, polyurethane is a far more efficient insulator than other materials. The applications of polyurethanes have been widening as their versatile properties of toughness, resistance to abrasion, lightness, insulation qualities and adhesive potential are put to an increasing number of uses. A quiet revolution has been in progress for the past 30 years, as their applications have broadened to almost every area of life. Yet because they're often covered up by other substances, their uses have often gone unnoticed. Polyurethane is the result of a reaction between two chemicals. Polyols made, for example, from sucrose derived from organic materials such as sugar beet, and a polyisocyanate, a derivative of crude oil. When these substances are brought together, there is an instantaneous exothermic reaction, in the course of which a new solid substance is created, polyurethane. No outside source of heat or energy is required to make the process happen. It is this reaction that makes the manufacture of polyurethanes different from most other plastics. There is no waste byproduct. The reaction takes place in a matter of minutes. It can be used to activate another chemical, the blowing agent, which expands polyurethane into a foam. Under microscopic inspection, this foam can be seen to have a cellular structure. By providing the raw materials together with suitable catalysts and additives, the properties of polyurethane may be varied according to its use. Unlike other plastics, which are delivered ready-made, the two components of polyurethanes are made up to the requirements of the manufacturer, who will carry out the reaction, making the final polyurethane product himself. Depending on the use to which it is to be put, polyurethane is applied by spray, poured, injected into molds, or laid down on continuous laminators. Its unique properties benefit the manufacturer because polyurethane can be made in exactly the quantities required. It needs no outside energy to form, and it's suited to continuous or batch process. Different blowing agents give it different properties, expanding it to make the variety of foams flexible, semi-flexible, or rigid. Another valuable feature of polyurethanes is that during the reaction, they are auto-adhesive, which means that they adhere very strongly to other materials, for example, to the sheet metal cladding of building panels. Because of its versatile properties, polyurethane has found applications in almost every area of life. Polyurethane can be used in every part of the home. Its tough properties are ideal for paint and coating floors. Its strength is used for building walls, while rigid polyurethane is probably the most efficient insulation available to the building industry, whatever the climate. Polyurethane's efficiency as an insulator explains its widespread use in every part of food cultivation and preservation. Its strength and toughness allow polyurethane to replace other conventional and more traditional materials such as steel and rubber. This in turn has led to freedom of car design and a higher standard of comfort and safety. The resulting weight reductions can lead to better fuel consumption. Fashion has made great use of polyurethane and makes the most of its lightness and resistance to abrasion. Since 1975, shoe manufacturers have been able to design new forms of footwear for all types. This shoe revolution can be noticed in sport shoes for very active sports, which place the shoe under conditions of high stress. It's a material so versatile, it's found a wide range of uses both in work and at play. These uses for polyurethane and its diversity of applications all stem from one seemingly simple chemical reaction. Polyurethane chemicals, like any chemicals, require sensible precautions to be taken in the manufacture, handling and use. The two main constituents, polyols and polyisocyanates, are manufactured in large chemical plants. These plants are subject to strict regulations. The materials are carefully handled by appropriate methods. Transport is carried out by using specialist transport contractors, who are also subject to inspection and strict regulations. In the event of an accident, however, various kinds of damage might occur. There will be some risk if the contents were spilled. Once formed, polyurethane is inert. It does not react with air or liquid, and its ability to withstand shock, its lightness and strength all add to safety. Like many common materials, polyurethanes can burn, and foam may burn quickly because of its high surface area. The rapid introduction of combustion-modified high-resilience foams that meet the stringent UK government fire safety requirements have done much to reduce concern over the risks of polyurethanes in soft furnishings. Surface coverings should always be chosen to offer protection against rapid fire spread. Polyurethanes play an active role in conservation because they can replace other organic materials which would otherwise be lost, such as trees, vital to the survival of the planet. This effect can be seen in furniture which uses polyurethane instead of wood and through its ability to conserve energy. The use of polyurethanes in conjunction with CFCs, the gases which are thought to harm the protective ozone layer, has, however, caused great concern. It has been the use of CFCs as the blowing agent for polyurethane insulation in refrigerators which has helped to give us efficient refrigeration. In response to international agreements on CFCs, ICI is spending millions of pounds on research with great success, developing alternative blowing agents and ways of using them. The use of CFCs is being phased out, and ICI is playing a leading role in this program. Polyurethane has a vital role to play in food preservation, reducing wastage and improving the standard of living. In other areas, polyurethane plays an active role in protecting vital pipelines and conduits, such as the Trans-Canadian fibre optics link. The environmental impact of polyurethane in conservation and preservation can make a significant and lasting contribution to the global well-being of our planet. Carbon dioxide emissions are thought to be the chief cause of the greenhouse effect and the consequent warming of the planet. Good thermal insulation will reduce the rate at which fossil fuels are burned to assist temperature control and will thus help to reduce these emissions. Since polyurethanes provide what are probably the most efficient insulating materials yet discovered, they have a significant role to play in the conservation of energy resources and the maintenance of balance in the environment of the future.